everyone, and thanks for watching Edupedia World videos. In this video, we'll discuss solutions to the questions in paper 1 of the 2013 JEE Advanced Physics paper. The order I'll be following will be the same as in code 0, but in any other order the questions will be the same, just the order will be different, so you can figure that out for yourself. In this paper, question 1 is a particle of mass m being acted on by a force which is k times x I cap plus by x squared plus y squared to the power 3 by 2 plus y j cap by x squared plus y squared to the power 3 by 2, and it is being taken along the Cartesian plane from the point a comma 0 to the point 0 comma a along this circular path. So because of this circular path and because of root x square plus y square in the denominator, I can see that it will be easier to work in polar coordinates. So we'll switch to those. X is equal to r cos theta, y is equal to r sin theta, which means that r is x squared plus y squared to the power 1 by 2, and theta is tan inverse y by x. So if you substitute these two values for x and y in f, you get f is equal to k times r cos theta I cap divided by, now this term is r cube, plus r sin theta by r cube, which is k times k by r square times cos theta I cap plus sin theta j cap. Now we know what this vector is, cos theta I cap plus sin theta j cap. If this angle is theta, this vector is a vector of magnitude 1 in this direction. So it is basically the unit radial vector r cap. So we can write f as k by r squared r cap. So this means the structure of f is such that the magnitude is inversely proportional to the square of the distance from the origin, and the direction is always radially outward. Right. So from this we can see that this force is exactly identical to the force on a particle of charge q, positive charge here, except for the constant k. This will absorb all the other constants. But if we keep a positive charge here and if we keep another positive charge here at the origin and move this charge about, then the force this charge will experience will be of the form of k by r squared r cap. But k in that case will be the original k multiplied by the charge of this multiplied by this charge multiplied by this charge. So that's absorbed into the constant, that doesn't matter. But this force is exactly the same as the force experienced by a positive charge moving in this quadrant by a positive charge kept at the origin. And we know for that the potential energy just depends on the distance between the two. So if the distance between the two is a here and a here, the potential energy is the same in both the cases. So the work done will be 0 and the answer will be D. But if you're not convinced of that, I can just quickly show you the rigorous way of proving that the work done will be 0. All we need to do is find the potential energy at this point, call it capital A, and this point, call it capital B. So the potential energy at capital A will be integral of minus integral of from whatever the reference is to the point R or A, f dot dr. Now to calculate the potential A, what I'll do is I'll take this particle along the x-axis from infinity to this point. We know that at infinity the potential is 0, that is what we always assume. So this will mean UA is equal to minus infinity to A k x I cap by, okay, this whole term multiply by dot dr. But dot dr in this case will simply be dx I cap, because there is no displacement in the y direction, and when you take the dot product the j term will cancel out. You'll just have x dx by x square plus y square to the power 3 by 2. Not only that, but y will be 0, right? So you'll get x by x square to the power 3 by 2 or x by x cube. I cap already joins with that and becomes 1. dx, which is minus infinity to a k by x squared dx, which is equal to, this will be x to the power minus 1 by minus 1 or 1 by x, so it will be k by a ultimately. And then you can do the same thing when you come from this direction. Infinity, whether it's infinity in the x or y direction, will give you potential 0, and if you come from infinity to 0 comma in the y direction, you'll see the potential energy is k by a again, right? So the potential energy is the same, that means the work done is 0. Thank you.